parents didn't want that, so they made it work.
Oh, I have absolutely no idea about all that. All right. So, anybody have any questions on this one? How many you have of each element? All right. And of course, it just becomes important because we're balancing equations. So we're going to start balancing equations today and do that for a couple of days. And then we'll do writing and balancing them. And then we'll start on different types of equations. So you should not need a calculator for a while. It's just kind of nice. Miss Binkley will be in here Thursday for my yearly evaluation. So that's always fun times. You have 2 quizzes this week. The first one is a Wednesday. That's just over balancing equations. And then the one on Friday is writing and balancing equations. And both of those will be open note quizzes. So there will not be any re-quiz on those 2. And that's kind of just what this is. If you did on the empirical molecular formula, if you need to retake that, it needs to be done by this Thursday. And my tutorials are listed here and also up on the board. I will say this, balancing equations, practice does make you better. If you struggle with it, it is something that if you practice and put a little time into it, it'll get easier for you. I don't know if you can say that about everything that we do, but it is true for balancing equations. And if you look at your practice, can I borrow yours for a minute? Most of this is just balancing. And the last page is what we'll start on Wednesday, I think. That's writing first and then balancing. Everything else before that is balancing your equations. And you'll see on some of the keys, I just printed them off the computer and they had ones written as coefficients, and you never write a 1. It's like you never write a 1 or subscript. So that's why I put that big note on there. Don't write 1s, even though it was on that key. All right. Anybody have any questions on that? We shall start some notes. All right. So we're going to start our new notes. So Ben and Jaheen, if you go into your Google Classroom, you'll find that under notes, chemical reactions. Do a couple of pages of that. I'm forgetting something, but I don't know what I'm forgetting. So, all right. All right, so we all know what a chemical equation looks like. I'll just put a very simple one. H2 plus O2 yields H2O. Remember, you start with your reactants and you end with your products. Sometimes it'll have what state everything is in. So like here, I would put G for a gas, and then water is a liquid. So sometimes, not always, but those are some of the things that you will see. Remember, on the periodic table, anything that is black is solid at room temperature. Anything that is red is a gas. So that's how I knew that hydrogen and oxygen would be gases. And there's 2 things that are blue, bromine and mercury, and those would be liquid at room temperature, because sometimes that does come into play. And here is when we really start using our diatomics. So the equation must contain the correct formulas for the reactants, which are before, and the products, which are after the arrow. The law of conservation of mass and energy said that atoms or energy cannot be created nor destroyed during a chemical reaction. And that's why we balance equations. So that means if we have to have the same number of atoms of each element on each side of the reaction. So if I go back to this reaction that I wrote, is that a balanced equation? No. Which element is not balanced? Oxygen, because if you look here, I have 2 oxygen, but on this side, I only have 1. When you balance an equation, you balance with the coefficients, which are the large number that are written in front of the compounds. So I would have to put a 2 there, which now made my hydrogen have 4. So that means I would have to put a 2 back over here. And that's often how it works when you're balancing equations. You correct one thing, and then you got to go to the other side and correct the other one. I could not just give this oxygen a 2 to make it balanced, because that completely changes the compound. It would change it from water to hydrogen peroxide. So you cannot change subscripts. You can only change coefficients to get things balanced. All right. So BC, the state of matter should be indicated for each product. And you'll see that on some of your equations, but not all of them, because sometimes that gets a little tedious. Remember your Brinkelhoff: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. When those are elements are all alone, they have to exist as diatomic or 2 atoms. So that's why you see H2 and O2. Those are both diatomics. I could not just put H plus O, because one hydrogen by itself or one oxygen by itself is not stable. Once I write water, H2O, there happens to be 2 hydrogen, but there's only 1 oxygen. I would not make that a 2. Now that oxygen is not by itself. It's part of a compound, so that diatomic rule falls away. We also have a couple of things that are polyatomic when they're by themselves. Sulfur is S8. That's a subscript of 8. Sorry, doesn't look like it. And phosphorus is P4. So that means when sulfur is by itself, it's 8 atoms together. When phosphorus is by itself, it's 4 atoms together. Once they become part of a compound, that falls away. All chemical changes are accompanied by some type of change in energy. A reaction that releases energy as a product is exothermic, and a reaction that absorbs energy as a reactant is endothermic. So hand warmers, if you've ever used those, like if you try to go hunting right now, you may need some hand warmers. You do that little disc and they go from room temperature to hot. That would be an exothermic reaction that's releasing energy, and we feel that as an increase in temperature. An instant ice pack would be opposite. Once again, you may activate it and it gets cold. It's endothermic. It's taking the energy in, and then we feel that as a temperature drop as it gets colder. All right, everybody got this? Move up a little bit. All right, let's talk about some things that you might see in a chemical reaction as far as symbols. Plus sign, obviously, you're going to see a lot. Separates 2 or more reactants or products. Our arrow means yields. Separates the reactant from the product. It does not mean equal to. If you have a double-headed arrow, that indicates a reversible reaction. If I have an S in parentheses, then that means that whatever product or reactant I'm looking at is in the solid state. And it would be placed after the formula of that substance or element. An alternative is an arrow going down. That also means solid, but only when it's on the product side. So that would be a reaction where I like mix something that was clear and something that was clear, and they came together, and then they ended up, because of the type of reaction, ended up forming a precipitate or a solid. So that's another indication, precipitate. Parentheses with an L indicates a liquid. AQ is aqueous. That means that the solute has been dissolved in water. You may also see that it's in solution. If something is in solution, it's been dissolved in water. So if you said that if you took salt and you put it in some water, you would say that the sodium chloride was in solution or was in an aqueous solution.
Would it matter if we made them uppercase?
Yeah, they have to be lowercase. Oh, and I guess that may be so that you don't get them mixed up with elements. I don't know why they made them all in lowercase. But yeah, they should be in lowercase. G for gas. Excuse me. And then an arrow going up can also mean gas, but same thing. That's only on the product side. Sometimes you may start with two liquids or a solid and a liquid and end up with the gas. And an indication of that may be some little bubbles within your liquid. If you see an arrow with a triangle over the middle, that indicates that the heat had to be supplied for that reaction to occur. Sometimes you'll see an arrow with some kind of element or compound over the top. I'm just going to put PT for platinum, but that's not the only one. And that indicates that a catalyst has been used in that reaction. In this case, platinum would be the catalyst. And if you remember from biology, a catalyst is used in the reaction, but it's not changed or used up, so it can be used again. So that's not why it's not written as actually part of the reaction. And then an arrow with ELEC stands for electricity. So that would be the electricity is needed for the reaction. And a shorthand for reaction is RX. So you'll probably see me kind of using that as we go through this. So those types are often called electrolysis reactions.
We use RX for like the pharmacy.
Pharmacy, yeah. All right. So just a little refresher next on counting atoms. And then we'll talk about balancing them. Y'all good? All right. All right. So you must be able to obviously count atoms in order to balance an equation. And there's two ways to designate the numbers in a formula. The first one is the subscripts. And those are the small numbers within the compound. And that tells you the number of atoms in that compound. So for instance, if I have MgCl2, magnesium chloride, since the magnesium does not have a subscript, it's always an assumed 1. We never write a subscript of 1. We never write a coefficient of 1. And then the chlorine has a subscript of 2. That 2 only applies to the chlorine. So I would have 2 atoms of chlorine. Here I have SNN. So that's going to be 10 nitride. So my 10 has a subscript of 3, so it has 3 atoms, and my nitrogen has a subscript of 2, so it has 2 atoms. You do not change the subscripts to balance equations. That's going to mess you up. You cannot change your subscripts to balance your equations. What you will be changing to balance your equation is your coefficient, which is a large number in front of the formula of the compound or the element. It tells you the number of molecules if it's a covalent compound, or the number of formula units if it's an ionic compound, or the number of atoms if it's just an element. And it affects everything behind it. So this 3 will affect my sodium, my sulfur, and my oxygen. So the best way to do this is find out how many atoms you have of the element within the compound and then come and multiply it by the coefficient. So for instance, on my sodium sulfate, if I look at my sodium, my Na, I have 2 atoms of sodium, and then I would take that 2 and multiply it by 3 to give me a total of 6 atoms of sodium in that particular compound. Sulfur, subscript of 1, even though it's not written, 1 times 3 is 3. And then my oxygen finally would be 4. And then 4 times 3 would give me 12 atoms. All right, why don't y'all try the next one, the calcium phosphate, real quick? This says sodium, but that should say calcium. All right, so how many atoms of calcium did we have? 12. And phosphorus? 8. Even though I have 4 written down in my notes. Can't multiply that day. And then my oxygen? 32. All right. Anybody have any questions on how we got that? All right, so let's talk about balancing. I'm going to talk about a little bit here, and then we'll look at your examples and do a few of those. So when you're balancing an equation, you have to write your equation using the correct formula. Right now, I've given you those formulas, but starting on Wednesday, you'll be writing and then balancing. Once the formulas are written, you do not change them again. So that means you cannot change the subscripts to get balance. To balance the equation, you have to do an atom inventory on both sides of the equation and use coefficients to balance the count. Often you'll get something fixed on one side and then it messes up something on the other side, so you kind of have to move back and forth on that. Okay, let's look at these and then we'll look at some on your, because this doesn't really have that much room. We'll do this part. All right, so we have water breaking down to make hydrogen and oxygen. So once again, this is one we already talked about. It's not balanced because of my oxygen. I have 1 oxygen on this side, but 2 on this side. So I need to put a coefficient of 2 in front of the water. I cannot just go in the middle. It would be nice if I could come and put my 2 right there in the middle between my hydrogen and oxygen, but I can't. So in other words, it's going to affect my oxygen like I wanted it to, but it also affected my hydrogen. So now I have 4 hydrogen. So I got to come back over here. So kind of some hints here. I would say work both sides of the equation. In other words, don't just put a 2 there and say, okay, I got that one thing balanced, I'm good. That means as soon as you put a coefficient, you probably need to go ahead and go back and check. Another one that really is represented in this equation is don't forget your diatomics, which today and tomorrow I've given you the equations, but when you start writing them, it's going to get you really messed up. So like if you saw this written in words, it would say water decomposes and forms hydrogen and oxygen. If you forgot that diatomic and just put H plus O, it's going to be wrong from the beginning, and then you can't ever get it right. All right, on my next one, I have lead nitrate plus sodium gives me sodium nitrate plus lead. So here, if you notice, instead of dividing out my nitrogen and my oxygen, if I keep my nitrate together as one unit, you can see that you have 2 nitrate. And over here, I only have 1 nitrate. So to get started, you're going to need to put a coefficient of 2. So now I have 2 nitrate groups on both sides, but what else did I change when I put that coefficient? I fixed my nitrate like I wanted to, but what else got changed because of that too? The sodium, right? The Na. And I didn't really want it to, but now I have 2 Na. So what do I need to come back on this side and do? Put my coefficient of 2 to get that sodium balanced out. So once again, working both sides, and treat polyatomics as one unit. Now, this is a special type of reaction that's called a combustion reaction. And actually, I'm going to skip that one for right now because we're really not there. All right, so pull out your practice because we have more room to work on the practice and all these notes are kind of crammed up. All right, let me pull up a practice.
Is it always 2?
Is the coefficient always 2? No. That would be nice. All right. Jaheen and Ben, we're going to go into practice balancing and writing equations because we have more room to work on it. Oops. Now, as I teach balancing equations, I'm going to do like a inventory tally. I do realize that some of y'all don't need to do that, and that's fine. Some people are real good at balancing equations and they can just look at it and figure out what coefficients they need and maybe erase a little bit if they need to. Other people need to go through this process. So whatever works for you is fine. Okay? No thanks. Let's make this a little bit bigger. All right, so remember the whole point of balancing equations is that you have the same number of each atom on each side of the equation. And it often means you fix one thing and you have to go back and change the other one. So I'm going to do a tally. I put a line where my arrow is to separate my reactants and my products. And then I list what elements I have. Fe is iron and O is oxygen. Remember, each time you see a capital letter, then that's when you have a new element. So if I have that on my reactant side, I have to have that on my product side. And I try to keep them in the same order because what you're going to be doing, you're going to be wanting to compare. So it's kind of easier to compare across than if you got to go up kind of skewed. So my first thing I do is I take a tally of how many atoms I have of each. I have 1 iron, and because of that 2, I have 2 oxygen. And then on this side, I have 3 iron and 4 oxygen. So that's going to be my first step. It's going to be correct when I have the same number of iron on each side and the same number of oxygen on each side. So I'm just going to start at the top. I have 1 iron on my reactant side and 3 on my product side. So I'm going to come to my side, which is lower. What coefficient do I need to use to get that balanced? A 3. So I'm going to put a 3 in front of my iron. So now I don't have 1, I have 3. And remember that 3 only affects the iron, and then it does not affect the oxygen because the oxygen is not part of that compound. So now I'm going to look at my oxygen. I got 4 here, and I have 2 here. So I'm going to go to my side that is smaller. Right now I have 2, but I would like 4. So what coefficient can I put in front to get 4 oxygen? 2. 2 times 2 would give me 4. And then that would be my balanced equation. I have 3 iron on each side and 4 oxygen on each side. We never put a coefficient of 1, so I would not put a 1 in front of my iron oxide. So that's kind of what I mean by the tally. And if you need to do then do that process. Some people don't have to, or maybe just need to do it on the tougher ones. Let me do another one here. We'll go and we'll do the same thing. So start off with what I have strontium and oxygen. I have 1 strontium and 2 oxygen. And on this side, I have 1 and 1. So right now my strontium looks good, so I'm going to leave it. So I got to deal with my oxygen. I have 2 here and only 1 here. So I've got to put a coefficient of what? 2. So remember, it affects everything behind it. So it changed my oxygen like I wanted it to, but it also changed my strontium, right? But that's an easy fix. To fix that, all I got to do is come back on my reactive side and put a 2 in front of my strontium. And then it would be balanced. It would be nice if I could have slid that 2 right inside there and only affected the oxygen, but you can't do that. It has to go in front of the compound. All right. Y'all want to try a couple? Let's see. Y'all skip 4. Why don't y'all try 3 and try 3 and 5? Those are good, easy ones, and then I'll come back and talk about 4 and 6. So why don't y'all give 3 and 5 a quick try? All right, so if you just take an inventory, that's all I started off here. I have potassium and bromine. So here I have 1 and here I have 2. And then on this side I have 1 and 1. So what's your first thing that you did? Put it here, here, where, in front of the KBR. Put a 2 in front of that, right? Coefficient of 2. Because if I look, the only thing that was off was my bromine. So I'm going to try to fix that. So it fixed my bromine, right? I got 2, but just like that other one, it also changed my potassium to 2. But that was an easy fix because all I got to come back and do is a 2 right there. So were y'all able to do it without having to do the tally? Or you, yes, no, some people? Like I said, usually when I teach this, some people it's really easy for them, and then some people really struggle with it for some reason. But I think that's pretty typical. We come across other things that work that way too. So this is going to be real similar to 1. So same thing. First thing, my iodine is off. Oops, this isn't a 1. How about that? Let's make that a 3. So, oh no, this is actually a little bit different. Okay, let's jump in the gun there. So I have 2 iodine on one side and 3 on the other side. So what coefficient did y'all put to try to even that out?
I put 3 on the right side and 2 on the left side.
So you put 3 here,
On the
this side. That's perfect. And 2 here. That balanced it. Because what you're going to have anytime you have 3 and 2, you're going to have to try to get 6 on each side. So I put that would have changed this to 2 and this to 6. So now I would have come over here. 3 times 2 would have given me 6. And I would have needed to make one last easy 2. And that would have gotten it balanced out. A 3 and a 2 are pretty common. And once you're doing that, if you're doing a 3 and a 2, you're going to have to do something to try to get 6 on each side. Number 4 is a combustion reaction. And if you notice on my product side, my oxygen is in 2 places. So that kind of makes it a little bit harder. You're just going to still do the total of your oxygen. But on these, if you have something, an element that's in 2 places, leave it to the last and see if it doesn't work itself out. So I have carbon, hydrogen, and oxygen, and I'm going to do the same thing here. So this is kind of like the one of the notes that I skipped. These can be a little bit hard. So I have 8 carbon, 18 hydrogen, and 2 oxygen. And then on my product side, I have 1, 2, and 2 here for my oxygen, plus another one, a total of 3. And right away, I can tell you what's making this a little hard is to have an odd number of oxygen. Because if I had an odd number of oxygen on my product side, how can I ever get that correct when I have a 2 over here? But like I said, we're going to leave our oxygen to the last. So we're going to start with our carbon. I have 8 here. I need 8 on my product side. So I'm going to put an 8 in front of my CO2. So it's going to change my carbon to 8 like I wanted it to. And if I look at my oxygen, 8 times 2, I have 16 plus another 1 here from the water to give me a total of 17. Still not going to worry about that oxygen. I'm going to hope it works out. I have 18 hydrogen here, only 2 here on my product side. So I'm going to put a 9 here. And 9 times 2 is 18. So now let's see what we have for oxygen. 8 times 2 is 16. And then plus another 9 for a total of 25. I'm going to erase some of these numbers. Things go on. For a total of 25. So obviously there's no way I can get this oxygen right here to 25 because it has that 2. It would always be an even number. So did anybody figure out what they needed to do to finish that out? If you have a number, you get stuck here and it's because you have an odd number. You need to multiply the coefficients that you have by 2. So I'm just going to give myself a little bit more room here. So 1 times 2 is 2. I'm going to leave my oxygen alone because that's the one I'm trying to fix. 8 times 2 is 16. And 9 times 2 is 18. Okay. So now I'm just going to real quick see where I'm at for my carbon. 8 times 2 is 16. 18 times 2 for my hydrogen is 36. I'm leaving my oxygen right now because that's the one I was working on. Now I come to my product side. 16 times 1 would give me 16 oxygen. My hydrogen, 18 times 2 would give me my 36. So the only thing I have left to worry about is my oxygen. Let's see what we got on our oxygen. 16 times 2 would give me 32. Plus another 18 from the water would give me 50. Finally, an even number. So split that in half would be 25. 25 times 2 would finally give me a 50, and that would be balanced. So if you get stuck on one and it's because you have an odd number, because that happens, try that little trick. Try and go with your coefficients and balance them. And and double them so you can get an even number. We'll look at this last one, number 6. All right. So number 6 has some polyatomics. It has this CO3, and CO3 is carbonate. So on my hint, I said instead of that dividing that up into carbon and oxygen, keep that together as one unit. So when I make my tally, I'm going to have calcium, I'm going to have carbonate, and I'm going to have sodium. And same thing over here. So I have one calcium. I'm keeping CO3 as one group, and I only have one of those groups, and I have one sodium. On my product side, I have one calcium. CO3 is one entity, one thing. I only have one of those, and I have 2 sodium. So this one looked kind of complicated when we started with it, but really to balance it, all we have to do is do what? Put a 2 in front of the sodium, right? And that's going to get that whole thing balanced. All right, so tomorrow, y'all are just going to have the period to work on your practice. Y'all have plenty of practice. And like I said, this really is something that I believe practice makes better when you do that. So we're going to do that tomorrow before we move on to our next thing. And quiz on Wednesday, just over balancing. All right, Ben and Jaheen, if y'all can leave if y'all want to. We're going to just continue on with the practice tomorrow. Okay? See y'all tomorrow. Y'all remember doing balancing from engineer